Hi guys, I hope you had a wonderful Easter break and enjoyed your time with your family. Today we are going to be moving on to section 4-2, which you can see is integer exponents. There are no vocab words, so we're going to jump right in. You need to be taking notes as I go. Make sure you have your math heading and take all the notes that you can. Feel free to pause the video at any point to jot down your notes and then keep watching. So the first thing I wanted to remind you of is how powers of 10 work. So we talked about this, we've talked about this before, but I just want to remind you how these positive exponents work on powers of 10 and also how the negative exponents work on powers of 10. Kind of gives you a feel for how these integer exponents work. So remember that integer should bring to your mind negative numbers. Okay, integers are also positive numbers, but they're negative number counterpart as well. So when we look at powers of 10, with a positive exponent, that power is going to tell you how many zeros you have after your 1. So if we have 10 to the power of 3, we're going to have a 1 and 3 zeros. 10 squared, or to the power of 2, we have a 1 and 2 zeros. 10 to the power of 1, we have a 1 and 1 zero. And 10 to the power of 0, we have a 1 and no zero. When you think about this pattern, which chances are if you're working on math, you're going to see some kind of a pattern. And here, hopefully it's pretty clear. When you have your standard form number here, so we have 1,000, 100, 10, 1, you should see a pattern that's happening. We're cutting off 1 0 each time, essentially. What that means is, mathematically, we're dividing by 10. So that pattern is going to continue down for our negative numbers, and we're still going to be dividing by 10, which means here we are going to have 1/10. Remember, you can think of this as a fraction as well. This one would be 1/100th, or 1 over 100, 100th. Regardless, when you have those powers of 10 with integer or negative exponents, rather than counting your number of zeros, like we did here, we had an exponent of 2, so we had 2 zeros. Here, we're counting how many decimal places we have. So with that negative exponent, we're saying we should have 2 decimal places. With this, we should have 1 decimal place. So if we added 10 to the negative 3, we would need 3 decimal places, and it would be 1 over 1,000. Now here, if you're doing it like a fraction, you do still have those 3 zeros that the 3 represents. So with a decimal, you're talking about how many decimal places you have. If you're going to write it like a fraction, it would be how many zeros you have after your 1. When we remember all this, so we are each time still dividing by 10. That pattern is continuing on the whole way. When we think about that pattern and what's happening, it will help us to understand what's happening with our negative exponents. So when we have this happen, we have a power of 10 with a negative exponent. Check out the fractions that you're getting. You could also think of these fractions as having a positive exponent. So if we think about 10 with a positive exponent, that's 10 to the first power. If we think about 100, that's 10 squared. So we have 1 over 10 squared. Here we have 1,000. 1,000 is 10 cubed. So we'd have 1 over 10 cubed. Check out the pattern that exists here. So we've got these 3 new fractions that correspond with these powers of 10 with negative exponents. Compare those. 10 to the negative 1, 1 over 10 to the first power. 10 to the power of negative 2 is 1 over 10 to the power of 2. 10 to the negative third power is 1 over 10 to the third power. So do you see what's here is in your denominator minus the negative number, or the negative sign, sorry. So if we have 10 to the power of negative 3, we're going to put 10 to the power of 3 in our denominator. The only thing that's disappearing is that negative sign. The way that that is going to disappear is that you make your 10 cubed your denominator. Your numerator is always going to be 1. Always. So with these integer exponents, you're going to make your numerator 1. Your denominator is going to be whatever your number in exponential form was. Just leave out the negative. So say we had 10 to the negative 4. That's going to equal 1 over 10 to the 4th power. Excuse me. We can, excuse me, goodness. We can simplify this and say 1 a 1 with 4 zeros. So there you go. If we want to write this in decimal form, when we have that exponent of 4, remember that we need to have 4 decimal places, and our final one would be the 1 from the 10. So we would have 1 10,000th, which is the same as this fraction, 1 10,000th. Remember that when you read a fraction properly and you read the decimal properly, they should sound exactly the same. So we have 1 10,000th, we have 1 10,000th. The next example is another power of 10, 10 to the negative 5. So we are going to make it 1 over. We're going to ditch this negative in our exponent by making it 1 over 10 to the 5th power. 10 to the 5th would be a 1 with 5 zeros. So it's 1 100,000th. And to write that as a decimal, you would have 5 decimal places, and your final one would be the 1. So again, we have 1 100,000th. Moving on to example 2, we have different bases now. So in example 1, we were just dealing with powers of 10. Now we have -2 for our base, and over here we have 6 for our base. You're going to deal with this in the same way that you would deal with it with the negative exponent with those powers of 10 by making it 1 over. That gets rid of the negative. Everything else stays. So we still have -2 for our base. Our exponent is now +3 rather than a -3. To figure this out, we are going to take -2, which is our base, And we're going to multiply that 3 times because our exponent was 3. So we have 1, 2, 3 negative 2's being multiplied. When we do that, I'm going to take negative times a negative, which would be positive. 2 times 2 is 4. So then we have 4 times negative 2. We'd have a positive times a negative, which would be negative. So our final answer here is negative 1/8. Over here, again, we have that negative exponent. So we have 6 to the power of negative 4. Get rid of that negative exponent. We're going to make this 1 over what's there without the negative. So our base is 6, our exponent is 4. That means that we're going to take 6 times 6 times 6 times 6. Do not fall into that common trap of multiplying your base times your exponent and saying 1/24. That is not what an exponent means. An exponent means that you're going to take that base, you're going to multiply it, and you're going to have the number of bases that your exponent is. So here we have 6's that we're going to multiply, and we have 4 of them. So we need to think about 6 times 6 times 6 times 6. When I do these, you might remember from the last lesson, I like to do it like this. And then I would say 36 times 36. Ooh. Guys got a little Spanish there from Ruthie. So we have 1,296. Remember your THs at the end there. The next thing that we need to talk about are powers of 0. So in our powers of 10 that I had up here earlier, I did have 10 to the power of 0, and hopefully reminded you that anything to the power of 0 equals 1. So no matter what your base is, if your exponent is 0, it's going to simplify to be 1. So oftentimes algebra books like to put some really complicated term and make the exponent be excuse me, make the exponent be 0. That whole thing then would simplify to be 1. So you can go to problem 3 now, and this is going to involve those powers of 0. It's also involving our order of operations. So please excuse my dear Aunt Sally or our poem that we learned back in 6th grade. Parentheses are number 1, then exponents must be done, multiply and divide left to right, add and subtract left to right. Those are the order of operations. Now let's do some math and have some fun. I think that was it. So the deal is here, you're going to be given some kind of either algebraic expression or just a numeric expression like this particular example is. We have 2 plus negative 7 to the 0 power minus, there we go. So that negative 7 to the 0 power, immediately we know that's going to simplify to 1 because anything to the power of 0 equals 1. When you look at this though, you need to remember those order of operations. So we need to think about, do we have any parentheses that need to be simplified? Well, yeah, we do right here. So we're going to do that first. And that will simplify to this. The next thing we do is exponents. So we can go ahead and take care of negative 7 to the power of 0, which is 1. And then we have 6 to a negative exponent. So those integer exponents, those negative exponents are going to need to be taken care of by making it 1 over and then exactly what's there without that negative. So this becomes 1 over 6 squared. We still have an exponent there that we need to deal with. Oops. So that becomes 1/36. Now we're going to multiply and divide left to right, which we don't have anything, so we are going to add and subtract left to right. So we add these, and please do not be freaked out by the fractions that are going to show up here. Think about your fraction sense. So before this continued learning started happening, we had our review of fractions and we talked about fraction sense. Here's one of those examples when if you think about what fractions mean, that is going to help you figure out what this answer is a lot quicker than trying to change everything to 36 and figure it out that way. So think about the fact that we have 3 wholes. So we have 3 wholes of something, and we're going to take away 1/36. So say we have 3 cookie cakes, and they're big cookie cakes that we divided into 36 slices. We have 3 of those, and we take 1 slice out, just 1. Not 1 from each cookie cake, just 1 piece of cookie cake, and we're going to eat it. If we do that, we will still have 2 full cookie cakes, and then the one where we took 1 slice out of it, we would have 35 of the 36 still left. So don't always feel like, okay, I gotta change this to 36, and 3 times 36 would be 108 minus 136, that'd be 107/36, and now I have to simplify that, and hopefully it works out to be that, because that's what it should be. Don't always feel like you have to do all this work. Use your brains, use your fraction sense, think about it. This particular section especially, you're going to be taking some fraction away from a whole number. When you do that, just remember to think about what the fractions mean before you go to this. Sometimes you're not actually in this section, I don't think at all. You're going to have to go to this. I think you'll be able to just think about it and figure it out. So that is actually all of the examples for Chapter 4, Section 2. So I have your homework assignment for Section 4.2 right here. If you want to go ahead and start that, feel free. It's page 168, 15 to 39 by 3s. You're going to do that, and then after you submit it, watch the video where I go over those problems and correct anything that you need to correct, ask any questions you need to ask, and we will have a Zoom later today that you can ask questions, or you can post questions on the discussion board. For those of you who would like a few more examples, I'm going to do a few more from the guided practice and independent practice sections in your book on page 168. So the first one that I'm going to do is another power of 10 with an integer exponent. So let's look at number 3. Number 3, we have 10 to the power of -6. When you do that, you can write it as a fraction, which would be 1 over a 1 with 6 zeros. This particular problem, though, if you read the directions, it says simplify, write in decimal form. So they don't want this fraction form, they want the decimal form. You can figure that out in 2 ways. One is to look at the fraction that you got, say it, and it will help you to figure out what the decimal would be. The other way would be to think about that negative exponent. With a negative exponent on a power of 10, the exponent is telling you how many decimal places you're going to have, and your last one is going to be a 1. So either way, we have 1/1 millionth, Here we have 6 decimal places, the last decimal place being a 1. When you go to the next section, it just says simplify. Simplify means that you are going to find a standard form answer. So let's look next at number 6. Number 6 says -3 -3 to the power of -4. It does not say decimal or fraction here, but I would highly recommend you just go to a fraction because, as I've said many times, algebra loves fractions way more than it likes decimals. So we're going to go to fractions here if it's not specified that we're supposed to go to a decimal. When you simplify numbers in exponential form that have a negative exponent, you are going to get rid of the negative by making it 1 over. It's always going to be that 1 on the top. So it'll be 1 over, and then this negative goes away, the base and the exponent remain. So we have -3 to the power of 4. What that means is we need to take -3 times -3 times -3 times -3. Negative times a negative is positive. There you go. We have 1/81st. Remember, with a negative number as your base, if your exponent is even, you know automatically that your answer is going to be a positive number. If our exponent had been negative, that would mean that our answer, or standard form, I struggle with explaining this. So if our exponent is even, our answer will be positive. If our exponent here was odd, then our answer would be negative. There you go. So even exponent, your answer is positive. Odd exponent, your answer would be negative. Moving on, we are going to go to number 9, which the directions for this one are also to simplify. But we have a longer numeric expression here, which is for, hang on, here is number 9. Couple of things to remember here. The first I want to remind you of is with exponents, remember that they belong to whatever is directly to the left of that exponent. So some of you might look at this 0 and think, okay, this whole thing turns to 1. Well, look at what's directly to the left of that exponent. It's just the 9. It's not a parenthesis with this whole thing in it. It's just the 9 that is being taken to that power of 0. So when we think about our order of operations, and we need to do these parentheses first, within the parentheses there are no other grouping symbols, but there's that exponent that we're going to have to deal with. So we would say anything to the power of 0 is 1. Now I can finish up what is in my parentheses. Now I have no other items inside the parentheses to deal with, so I'm going to move to my exponent over here, which it's negative, so I need to make it 1 over my base and my positive exponent. 5 to the third is 125. And do my multiplication. Now I need to add all this together. With adding, these fractions are even easier than with subtracting. I'm going to add up my whole numbers, and then my fraction just kind of joins on. So I have 13 and 1/125th for my final answer here. One final example, I'm going to show you number 22. Now this has that power of 0 directly to the left of it. We have the parentheses. What that means is everything in these parentheses is being taken to the power of 0. So we do not actually even need to add what's in there. We know whatever it is taken to the power of 0 is going to be 1. So that saves us a step there. The rest we will copy down. And we have nothing else in parentheses that needs taken care of. So now we work on our exponents. To get rid of that negative, we make it 1 over the base times the positive exponent. We can do this exponent and say -3 times -3 would be a +9. Remember that when you are adding, you can do the addition in whatever order you want. So we can go ahead and say 3 minus 1 would be 2, and then we still have that 1/9 hanging around. So our final answer would be 2 and 1/9. That is the last example I'm going to do for section 4.2. You have some problems here to try. It's on page 168, 15 to 39 by 3s. And I want you to try those and then watch the video where I go over those. You will have an opportunity in the Zoom today to ask questions about 4-2. So I will see you later in our Zoom session.